objective reality emerges from quantum uncertainty researchers have demonstrated a key mechanism, explaining how the fuzzy, probabilistic nature of the quantum world gives way to the clear, consistent reality we experience. The study confirms that agreement on objective reality doesn't require perfect measurements, but arises naturally even from imperfect observations, supporting the theory of quantum Darwinism. The puzzle of classical reality at the quantum level, particles exist in a superposition of states until measured. However, everyday objects appear definite, with no quantum fuzziness. For decades, physicists have sought to explain this transition from quantum uncertainty to classical certainty. The leading explanation, proposed by Wojciech in 2000, is quantum Darwinism. This idea suggests that certain quantum states are more fit for survival in the environment, meaning they replicate themselves more effectively through interactions with their surroundings. Observers then perceive these dominant states as objective reality. If multiple observers independently observe the same replicated state, they agree on what is real. Imperfect observations still lead to agreement. A new study by Steve Campbell at University College Dublin and colleagues has now shown that even crude measurements can lead to objective agreement. The team recast the problem as a matter of quantum sensing. How much information about an object's properties, like light frequency, must be gathered to reach a definitive conclusion, using a metric called quantum Fisher information. QFI, they calculated how efficiently different measurement schemes could determine an objective property. Surprisingly, the results revealed that observers making imprecise measurements could still converge on the same conclusions, given enough data. A silly measurement can actually do as well as a much more sophisticated measurement, says Gabriel Landy of the University of Rochester. That's one way of seeing the emergence of classicality. When the fragments become big enough, observers start agreeing even with simple measurements. Implications and future research. This research bridges theoretical quantum Darwinism with practical quantum experiments, making it easier to test in real-world systems. Diego Wisniewski at the University of Buenos Aires notes that QFI, a core concept in quantum information theory, hasn't been applied to quantum Darwinism before, potentially opening new experimental avenues. G. Massimo Palma at the University of Palermo adds that while this is a significant step, more complex systems need to be modeled to solidify the theory further. Landy and his team are already planning experiments with Trappist qubits to compare the timescale for objectivity's emergence with known quantum properties of the qubits. In essence, this study shows that the emergence of classical reality isn't about perfect observation, but about the sheer volume of environmental interactions that select for stable, replicable quantum states. The findings reinforce the idea that our shared experience of an objective world is not a fundamental property of nature, but an emergent phenomenon.